In physics, how we talk about motion, well, it's everything. It's the real difference between knowing exactly where you need to go versus just knowing how far you've walked. Today, we're going to decode that secret language by getting a handle on two fundamental ideas: vectors and scalars. So, it all kicks off with a question that seems pretty simple at first glance. What's the real difference between distance and displacement? I mean, they sound almost the same, don't they? But in the world of physics, they describe two totally different things. And this really gets to the heart of it. One of these ideas just gives you a number, a magnitude, the how much. The other gives you that number times and a direction, the where. And that one extra little piece of information, it might not seem like much, but trust me, it's what allows us to truly analyze and predict how things move. All right, so first up, let's talk about the simpler concept: quantities that are really just a number with no direction attached at all. In physics, we call these scalars. Think about it like this. Let's say you call a friend and tell them, "Hey, I'm 5 miles away." That's a scalar. It's a number, a quantity. But it's not very helpful, is it? 5 miles in what direction? Now, if you say, "I'm 5 miles north of here," now that's a vector. You've given them the how much and the where. Now your friend can actually find you. So for the official textbook definition, a scalar is any physical quantity that you can describe with its magnitude or its size all by itself, no direction necessary. And you use scalars all the time, probably without even thinking about it. The temperature outside, the calories in that candy bar, the speed limit sign on the road, your own height, these are all scalars. Now, you might be looking at temperature and thinking, wait, what about negative 20 degrees? But that minus sign isn't a direction, right? It's just a point on a scale that happens to be below zero. Okay, so that's scalars. But what happens when we add that super important second piece of the puzzle, direction? Well, that brings us into the world of vectors. A vector is just any quantity where you need both a magnitude and a direction to really know what's going on. It's not enough to say how much, you've also got to say which way. So a car traveling at 90 kilometers per hour east isn't just its speed, it's its velocity, that's a vector. The force of gravity pulling you toward the center of the Earth, that's a vector. And yep, there's our other word, displacement. That's a classic vector. We usually draw them as arrows, where how long the arrow is tells you the magnitude and the pointy end shows you the direction. But here's the thing, to talk about direction in a way everyone understands, we can't just point and say that way. We need a map, a shared frame of reference, and in physics, we call that a coordinate system. This jet is a perfect example. For simple, one-dimensional motion, just moving back and forth in a straight line, our map can be incredibly simple. It can just be a plus or a minus sign. We get to decide which way is positive, and the opposite way automatically becomes negative. This is the key step that lets us turn a real-world situation into a math problem we can actually solve. Now, the standard way to do it is to say right and up are positive and left and down are negative. But here's the really cool part. You get to choose. If it makes the math easier to say the jet's forward motion is positive, go for it. The only rule, and it's a big one, is that once you pick a system, you have to be consistent for the whole problem. Okay, that's enough theory for now. The best way to really get this stuff to click is to apply it. So let's walk through a problem together step by step. Okay, here's the scene. Picture a car driving around a sharp corner. The whole time you're looking at the speedometer and it stays locked in, perfectly steady at, say, 30 miles per hour. But obviously the car is turning, it's changing direction. So knowing that, is speed a scalar or is it a vector? All right, let's break this down and pull out the important clues. The problem tells us two things. First, the magnitude of the motion, which is the speed, is constant. It doesn't change. And second, the direction of motion is changing. And that leads us right to the critical question, doesn't it? Which type of quantity, a scalar or a vector, actually cares if the direction changes? Just think back to our definitions for a second. And the answer is speed is a scalar. Remember, scalars are only about magnitude. They just care about the number. Since the car's speed of 30 miles per hour didn't change, even while its direction was changing, speed has to be a scalar. Now the car's velocity, that was changing the whole time, because velocity is a vector and its direction was constantly shifting. Great job. Now, to make sure these ideas really stick, let's run through a quick practice quiz. I'll ask a question, you can pause and think about it, and then I'll walk you through the answer. First up, a student writes this in their lab report.
A bird diving for prey has a speed of -10 meters per second. What is fundamentally wrong with that statement?
Well, here's the deal. Speed is a scalar, which means it can't be negative. That minus sign is trying to show a direction. In this case, probably downward. And as soon as you have a direction, you're not talking about speed anymore. The student has actually described the bird's velocity.
Okay, quick follow-up on that one. If the bird's velocity is -10 meters per second, what is its actual speed? It's just 10 meters per second. Simple as that. Speed is the magnitude of velocity, and magnitude is always a positive value. It's just the number part, without any of the directional plus or minus signs. All right, last one, and this one's a little trickier. We define acceleration as the rate of change of velocity. So based on that key definition, do you think acceleration is a vector or is it a scalar? It has to be a vector. The clue is baked right into the definition. Acceleration is the change in velocity. And since velocity is a vector, any change to it has to be a vector too. So if you speed up, slow down, or even just change direction, you are accelerating. That means acceleration itself must have both a magnitude